Hi Gr9s, I hope you are enjoying the Forcework Energy Power booklet. In your last video with Dr. Thornton, she actually finished off the content for that booklet. So the rest of this booklet is just practice calculations. She did number 1 with you already on page 11. So you were then required to do a few on your own. I'm going to be going through some of those with you. And if you still have questions after watching this video, then you need to message Dr. Thornton or myself and we will help you with your questions. So I'm going to start with number 2. Chewbacca is standing on top of a small hill that's 5 meters high. If Chewie has a mass of 112 kilograms, what is his potential energy at this height? Okay, so sometimes when you're dealing with questions like this, it might be a little good idea to draw a quick little diagram. So there's the hill, there's Chewbacca, he's standing on top of the hill, and the hill from the ground to the top of the hill, that height is 5 meters. His mass is 112 kilograms. Because the height is in meters, you don't need to convert. Remember, meters is already SI unit, and the mass is already in kilograms, which is a SI unit for mass. So leave those answers as they are, no conversion necessary. So the height is 5 meters, mass is 112 kilograms, and they want to know what is his potential energy. Remember, potential energy is measured in joules. So formula for potential energy equals to mass times gravity times height, which is equal to 112 times gravity on Earth, which is 9.8. It's better to write in brackets, so I'm going to actually do that in this example. Gravity on Earth is 9.8 meters per second squared, and his height above the top of the hill was 5 meters. If you multiply that together, you should get 5,488 joules. If in a question like this, we told you that Chewbacca was wearing a red t-shirt, and it was cloudy that day, and he stood on the top of the hill for 5 minutes, and Chewbacca's height was 1 centimeter. None of that information is relevant. You just want to know what his potential energy is at 5 meters above the top of the hill. The color of his t-shirt, how long he stood on the top of the hill for, that information is irrelevant. So beware in tests and exams. If we give you extra information like that, for example, the time that he stood on the top of the hill for, ignore it. It's to distract you. So you need to know, for calculating potential energy, the only 3 variables you would need is mass, gravity, and height. And of course, gravity we will give you as 9.8 meters per second squared. Alright, so question 3. Which of the following has a greater amount of energy? A TIE fighter with a mass of 12,000 kilograms. I could have also said that is actually 12 tons, because 12 ton means times 1,000, and 12,000 kilograms is the same as 12 tons, traveling at 200 meters per second. Or B, an AT-80 with a mass of 4,000 kilograms on the side of a mountain at a height of 7 kilometers above the ground. So let's work out what A's energy is. So the mass for A is 12,000 kilograms. The velocity for A is 200 meters per second. And that allows us to calculate the kinetic energy for the TIE fighter. So the formula for kinetic energy is half mv squared. So half, I've written that fraction, I've written as 0.5, and you can keep it as fraction form if you want to. The mass is 12,000 kilograms. You don't need to convert because it's already in SI units. Like I said, I could give it to you as 12 tons. You would need to convert 12 tons to 12,000 kilograms. I could say it's 12 million grams, and you would need to know to convert grams to the SI unit for mass of kilograms. The velocity was 200. Please don't forget that you have to square that. And that comes from the kinetic energy formula. Please don't ever forget to square your answer for that. Not square your answer, but square just the 200. Okay, and if you put that into your calculator, you should get that it's 2.4 times 10 to the 8 joules. So that's the amount of energy for the TIE fighter. Let's work out how much energy the AT-AT has got. So its mass is 4,000 kilograms. You don't need to convert, it's already in SI units. The height above it from the mountain, from the height of the mountain above the ground is 7 kilometers. And if you've got mass and you've got height, and we're going to use gravity, I know we're not really on Earth, but let's just pretend that we are on Earth. Gravity 9.8 meters per second squared. That allows you to calculate potential energy. Formula is mass times gravity times height. So 4,000 gravity 9.8, height of 7. That 7 you would need to rewrite as 7,000 meters because it's not an SI unit. So please times 1,000. So 7 kilometers, kilo means times 10 to the 3. 7 times 10 to the 3 is 7,000 meters. Please do not substitute just 7 into your formula like this. It will be wrong. Your whole answer will be wrong. You would need to write it as 7,000 meters. That will give a potential energy of 2.74 times 10 to the 8 joules. Once you've got these two values, 2.4 times 10 to the 8 and 2.74 times 10 to the 8, obviously you can see that answer B is bigger. So the AT-AT's got more potential energy. So if you're given a question like this in a test or exam, you're not finished yet by doing your two calculations. You still need to do one more little answer, which is to explain. Therefore, so even though you've calculated the kinetic energy for A and the potential energy for B, you're still calculating energy. You're still getting your answer with values that have got joules as the units. Okay, so you're still comparing different energies, but they are still energy. So potential energy and kinetic energy, they are still types of energy. And obviously, like I said, 2.74 is greater than 2.4. So please don't also forget to write that as your final answer. If Anakin is standing on the top of a ledge 15 meters above the ground and he has 10,740 joules of energy at this height, calculate his mass. So let's write down the information that we're given. Height, 15 meters. If I told you that it was 150 centimeters, you would need to convert that to meters. I haven't done that, but in tests and exams we probably will. He has 10,740 joules of energy. Again, if I told you that that was 10.74 kilojoules, you would need to go 10.74 times 10 to the 3, because that's what kilo means, and you would then get that answer. Alright, so we've got his height, we've got his potential energy, and we need to calculate his mass. Remember, mass measured in kilograms. Gravity on Earth, 9.8 meters per second squared. Minus 2. Alright, so EP equals to mass times gravity times height, which is, substitute in for gravity, substitute in for height. I hope when you do your calculations you have been putting in your substitution steps, because you will get a mark for doing it in tests and exams. Potential energy was 10,740 joules. Alright, so let's keep mass on that side. So we're going to divide both sides of our equation by 9.8 times 15. So divide the right hand side by 9.8 times 15, divide the left hand side by 9.8 times 15. And so we actually get that our mass is 10,740 divided by, when you do this in your calculator, make sure that you put that into brackets, otherwise you might get the wrong answer. If you haven't already done this, don't just copy down from the memo. Actually make sure that you can put these values into your calculator, because if you can't, we need to figure out why now rather than when you do a test or exam. Okay, so this intermediate step where you divide is not required, so only the blue writing is required. What I've written in red you don't actually have to write, I'm just showing it for explanation purposes. Only the blue writing is required. So that will give you a final mass of 73.06 kilograms. Okay, let's go on to number 5. How fast would Finn, with a mass of 110 kilograms including armor, have to be running in order to have 10,000 joules of kinetic energy? Again, just as an example, I could say that that is 10 kilojoules of energy. I could say that the mass is 110,000 grams. I could say that it is 0,110 tons. If I gave you either of those options, you would need to rewrite it with units of kilograms. If I give you an answer that's not in joules, for example kilojoules, you'll need to convert your answer with the SI units to have units of joules. Okay, so his kinetic energy is 10,000 joules. His mass 110 kilograms, and gravity on Earth is 9.8 meters per second squared. Okay, so kinetic energy, half times mass times velocity squared. So kinetic energy is 10,000. Half times its mass, which is 110, times velocity squared. You would then have to divide both sides by a half times 110. Then what you do to the right hand side, you'd of course have to do to the left hand side. A half times 110. When you're putting this in your calculator, make sure you go 10,000 divided by and then put this in brackets. Otherwise your answer will be wrong. Again, what I've written in red, not required. It's just for explanation purposes in case you didn't understand how to do this calculation. What I've written in blue though, everything that I've written in blue you will need to write down for tests and exams. You can either write 55 here, or you can keep it as a half times 110. But if you want to write 55, that's fine too. Okay, and then you get that v squared is equal to 181,82. But you are not finished. They didn't ask you to calculate how fast, so when they said calculate how fast, they were asking for v. They didn't ask for v squared, so you then need to square root that answer. And if you square root both sides of your equation, the square will cancel out the square root. But those cancel. So actually what we need is just v, and just v will give us 13.48 meters per second. 13.48 meters per second. You should also specify direction, which is forwards or in the direction that he's heading, but that we'll look at more next year. Okay, what height would an Ewok with a mass of 15 kilograms have to be above the ground in order to have the same amount of potential energy as the kinetic energy he would have to have if he was running at 1.5 meters per second? So a bit of a complicated question. Let's first calculate his kinetic energy when his mass is 15 and his velocity is 1.5. We'll see what his kinetic energy is then. And then we're going to put kinetic energy equal to potential and solve for potential energy. All right, let's go. You're going to have to write a little bit small for this one. So his mass will remain constant whether you're calculating what throughout this question. So his mass is 15 kilograms, is already SI units, so you don't have to convert. So if he was running at 1.5 meters per second, what would that kinetic energy be? So kinetic energy is half times mass times velocity squared. So I've got a half times, let me use brackets, a half times his mass, which is 15, times his velocity, which is 1.5. Do not forget to square your answer for 1.5, not your whole answer, just square the 1.5 only. Okay, so that's going to give us 16,88 joules of energy. (16.875), or round it off to 2 decimal places, 16.88. And then if we it's going to have the same means equal in maths. So to have the same amount of potential energy as kinetic energy, we're going to say potential energy equals kinetic energy. What is the formula for potential energy? Mass times gravity times height. And we're saying that the potential energy will equal the kinetic. So I can actually take this answer and substitute it in there. So our potential energy is going to be 16.88. We know his mass, it's still 15. He hasn't got fatter or lost weight, so he's still got a mass of 15 kilograms. Gravity, we're still going to use the value of Earth for 9.8. And height is what we're trying to calculate. How high would he have to be, or at what height would an Ewok have to be above the ground in order for EP to equal EK? Okay. So again, I'm just going to use red to show the calculation, what I'm dividing by. You don't need to do this in red. So you're going to have 16.88 divided by 15 times 9.8, and that will equal to the height. When you solve for height is 0.11 meters. So that's your final answer. Alright, so the energy that's being converted here, you've got an ice cream, so that's chemical energy, chemicals in the food and the ice cream that you eat, to kinetic if you're moving on a bicycle. Sunlight is light energy, and plants harness that energy and use it. The process is called photosynthesis. So plants convert it into chemical potential energy. This is also chemical potential energy. I'm not going to write potential energy, just light energy to chemical energy. Chemical energy in petrol allows your car's engine to convert that chemical energy into kinetic energy so that your car will move. And we've got an electrical plug socket, so that'll be electrical energy being converted into, in a stove or an oven, it'll be thermal or heat energy. Electrical energy gets converted into thermal. Note, we'll often give you a question about energy conversions in a test or exam and ask you what energy conversion has taken place. If you've got what we call a battery or a cell, like a Duracell battery or Energizer battery or cell, it's actually chemicals inside there. So you need to go one step backwards. You say chemical energy gets converted to electrical energy, and you can use that electrical energy to make a light bulb give out light energy, or a heater give out heat energy, or make a fan move. A fan moving would be kinetic energy. Okay, so let's put it all together. So that, up until now, when you've done energy, you've just had energy calculations. When you've done power, you've just had power calculations. Now we're going to mix up everything all together, and you'll have calculations involving where you have to take, say for example, your answer for work equals force times distance, and then use that in a power calculation. So that's one such formula that you're going to be using. Work is equal to force times distance. And you've got another formula, power equals to work divided by time. So I could give you a question where with power and time, so you'll have power and you'll have time, you'll then have to calculate work and use that answer for work in another equation. Might be a good idea to do the little magic triangle thing for these. So for example, work, force and distance. You've got another one, Fg or weight, same thing. Force of gravity on Earth is known as weight. Remember, G on Earth is 9.8 meters per second. And our energy formulas, EP equals mass times gravity times height. Know how to rearrange this formula. So for example, if you want height, height would be EP divided by mg. If you wanted g, g would be EP divided by m times h. And if you wanted m, m would be, don't write this please, m would be EP divided by g times h. So you need to be able to rearrange those formulas into what you need. You will be given the basic formulas in tests and exams, but you won't be given the so-called magic triangles. Okay, you got the last energy formula, EK equals to a half mv squared. So with this new knowledge, I now want you to start working on the mixed calculations, and the answers for these will be done in a separate video.